So we mentioned that alkynes have a DBE of 2 because every triple bond is a degree of unsaturation, which is 2. For the triple bond, the bond angle of the triple bond is always linear, and that is 180 degree. I mean, the geometry is linear and the bond angle is 180 degrees. And the hybridization for each of these carbons is going to be an sp hybridization. The simplest form of alkyne is a structure with two carbons separated by a triple bond. And this one we can name it either common or IUPAC. So if you want to name it as IUPAC, that is called ethyne. So ethyne is the IUPAC name of a structure which is made up of two carbons and a triple bond. And to name it as a common name, it is called acetylene. Acetylene is a common name. As I said earlier, that common names for these small alkynes and alkanes, they follow no rule. And you're only responsible to know the common name of a two-carbon alkene and the common name for a two-carbon alkyne. So in order to name alkynes, all what you need to do is drop the A and E of the alkane and replace it by a Y and E for the common. So your ending over here is going to be in the Y and E. As we did in the alkane, in the alkenes, we're going to do exactly the same. When you choose your longest carbon chain, you want to make sure to include the degree of unsaturation in there, meaning that you have to include the triple bond in there. Please pay attention that the triple bond is always linear. So the bonds that are connected to the carbons on the sides, they have to be a straight line to be able to do the 180-degree angle. If I want to go ahead and choose the longest carbon chain for this structure, that see how did I draw it as a straight line in there? Because this is a skeletal form and you do have a carbon here and you do have a carbon here. Don't forget. And this is an 180-degree angle. So you choose your longest carbon chain that includes the triple bond. Count your number of carbons here. I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So you're ending in this case, again, drop the A and E instead of nonane. That will be nonine. So that is going to be known. And drop the A and E and put a Y and E in there. So it's going to be an O9. You have to specify. If your triple bond is not on carbon number 1, you have to specify where it is and you have to give it the lowest number possible. So the lowest number possible in there for the triple bond, meaning that I need to start numbering it from this side. So the name here is going to be 2. No 9. I don't have a substituent, so this is the name. Another way to represent 2 no 9 is simply by putting the parent name in there, putting a dash, and then putting the 2 before the Y and E just to indicate that the triple bond is on the second carbon. Okay, let's have another example. This one with the substituent, so I'm going to choose the longest carbon chain with the degree of unsaturation. Okay, always your longest carbon chain should include the triple bond. Even though if you have two routes in there, one is shorter than the other, but the shorter one includes the triple bond, please choose that shorter route and make it your parent chain. So always the parent chain should include the degree of unsaturation. Here for this structure, my DBE is equal to 2 because I only have one triple bond. And then we're going to start numbering the structure in there. So we're going to give the triple bond the lowest number. This is my priority. So I'm going to start numbering from here. And that is going to be 1, 2, 3. Don't forget, this is a carbon. So all of those are carbons in there. This is a carbon as well, 4. This is 5. But again, I am drawing it as linear. in there with a bond angle of 180 degrees. And then you have 6, 7, that's 8, 9, and then you do have 10, and you do have 11 in there. So notice that I went this way and I didn't go the other way, even though I had the same number of carbons. But remember what we said when we were naming the alkanes, that you need to choose the chain with the most number of substituents. So make sure to do that. And if I go this way, then I'm going to end up having 2 substituents, and then the number of substituents are 2, and these are my substituents. I have a methyl and I do have a propyl in there. Okay, the M comes before the P, but I don't care about the numbering because I care about giving the triple bond the lowest number. And then name it as usual. Start with alphabetizing the substituents. So that is going to be 9-methyl, 8 propyl, and then 3. It's 11 carbons, so it's going to be an undecyne. We're going to do the same thing over here. The priority is for the triple bond. Always, whenever you are doing the IUPAC name and you have a degree of unsaturation, your triple bond is the priority. Even though the chain has less carbons than the cycle, it doesn't matter because you are not working with alkanes anymore. You are comparing alkanes or cycloalkanes with alkyne, so definitely alkyne is going to be a higher priority. So we're going to choose the longest carbon chain, including that triple bond. We're going to give the triple bond the lowest number. This means that I need to start numbering from here. Don't forget the carbons of the triple bond. This is 4, this is 5, and you have 6 in there. We do have 2CH3, so that is going to be dimethyl. On carbon number 5, on carbon number 1, I do have my cyclohexyl group in there, so that the name is going to be 1-cyclohexyl. And then on 5, I do have 5,5-dimethyl. And then, of course, my longer chain is going to be hexyne, but the triple bond is on the second carbon. So I have to specify where my triple bond is, and this is going to be hexyne like that. Okay. Now, let's say if you have more than one double bond, then in this case, your longer carbon chain should include all the degrees of unsaturation. You cannot include one without the other. Even though you are working with a shorter route, it really doesn't matter. All degrees of unsaturation has to be included in there. And then go ahead and circle your substituents. I have an ethyl group. I have a methyl group in there. And always the first degree of unsaturation, if you have multiple, the first one needs to get the lowest number. But here, if you start numbering from the side, this first triple bond will be on the second carbon. If you start numbering from this side, it will be on the second carbon in here. So these two triple bonds will carry the same number of carbons regardless what side you pick. Then now you need to go by the substituent and give the first substituent the lowest number. Both will get the same number on both sides, so you would need to go by alphabetical order and give the first alphabetical order the lowest number. The E comes before the M. So the E here comes before the M, and this is why I started numbering from here. So the name is going to be 4. It's going to be ethyl. I do have 5-methyl. And then on carbons 2 and 6, notice that the triple bond starts at 2 and it starts at 6. Not the 3, 7, 2, 6. So that is going to be 2, 6. And I do have my, it's a diene. And we're going to follow the same rule that we did for the alkene. Remember where we did put the A. in there. So that is going to be oct. I know that it is a diene, but it makes it be pronounced better if you go ahead and you introduce, let's put it in a different color, an A in there. So that is going to be octadiene, and you only put the A whenever you are using the prefixes di, tri, tetra before the degrees of unsaturation, whether it's a double bond or a triple bond. But make sure that every single degree of unsaturation gets a number. So I have two triple bonds and I have two numbers in there indicating those two triple bonds. The die is a must. Now, if I ask you, how many DBEs is this structure? All what you need to do is simply go ahead and count the number of degrees of unsaturation. This is 2 degrees of unsaturation. This is 2 degrees of unsaturation. So this structure is going to end up having a DBE of 4. Just add them up, or add all the degrees of unsaturation. For this structure here, the DBE is equal to, I know that the cycle is a DBE of 1, the double bond, the triple bond is a DBE of 2, then the DBE total is going to be equal to 3. Okay? Now, if I have a system where I have both alkenes and alkynes in the same structure, there is a priority order that you would need to follow, that the triple bonds always are a higher priority than the double bond. What does that mean? It means that your ending is always, always, always going to be in the Y and E instead of the E and E. Okay? So what are the rules? There are different cases in there, like 3 cases. So let's go over them. Always whenever you want to choose your longest chain, you want to make sure that all the degrees of unsaturation belong to that chain. This is the first thing. So if I am looking at a DBE here, if I'm looking to find the DBE of the structure, this is a DBE of 1, this is a DBE of 2, so this structure has a DBE equal to 3. Okay? Now, if I want to go ahead and number, the rule says that you start numbering from the first degree of unsaturation. It doesn't matter if it's an alkene or if it's an alkyne, your numbering has to be from the first degree of unsaturation. Here, in this example, the double bond comes before the triple bond. The double bond is at the end, so this is why the numbering has to be from the double bond. This is a 3, 4, 5, 6, and 7. Again, most of you will end up forgetting these 2 carbons around the triple bond. These are actual carbons. Don't forget them because these are carbons of the chain. So over here, I know that the ending is going to be hept because it is a chain of 7 carbons in there. Now notice that I do have 2 degrees of unsaturation. So I need to give a number for each one, and my ending has to be in the ine. So what I would do is I would do hept in there, and I would do a dash. I'm starting with, on carbon number 1, I have my alkene, which is the ENE, okay? And then on carbon number 5, I have the YNE. And this is how you name a system that has a double bond and a triple bond. You put the parent name first, and then you put your, where is the alkene located? So this is going to be the double bond part, and this here is going to be the triple bond part. And every time you include your double and the triple, you have to include where they are in the chain. Your ending is always going to be in the Y and E, no matter what, because alkynes, they have higher priority in naming than alkenes. Now, let's say if both degrees of unsaturation are on the same end, meaning that they get the same number. In this case, you always give the double bond the lowest number, but your ending is always in the Y and E. So this means that I'm going to choose my chain that includes all the degrees of unsaturation, and then I'm going to start numbering from my double bond in there. So this is 1, 2, 3, 4, 5, 6, and 7. And notice this is a carbon. Notice here, how did I write it? This is a 180-degree angle, so I need to write it as a linear. It has to be as a linear in there. Okay, and the ending here is a CH. So I don't have any substituents, so I'm gonna name it as before. So that is going to be hept. And on carbon number 1, I do have the ene. And on carbon number 6, I do have the ine. I could have named it, for example, I could have named it drop the 1. There's another way to name it. I could have dropped the 1 up there, which is similar to the other one. I could have dropped the 1 and said heptene. So that immediately will make the double bond on carbon number 1, and then it's going to be 5-ine. We'll do the same thing in there, so you can do heptene, and then 6-ine, still showing that the triple bond is a higher priority, and this is why the ending is in the triple bond. If you have, it's this case over here, where your first degree of unsaturation gets the lowest number, unless they are both first, whether on this side or the other side, then the double bond gets the lowest number, but the ending is always in the YNE. So here the first degree of unsaturation gets the lowest number, so I have to start numbering from here. It's going to be 1, 2, that is a 3, that is 4, you have 5, 6, 8, and 9. So your ending in there, it's going to be in the ine. So I need to put 1-ine in there. This is going to be my ending. And I do have a known. The double bond is on carbon number 6. So it's going to be known 6-ene, 1